how can we write the expression for the shaded region? Well, that's just going to be the integral from a to x of f of x. Ooh, I don't like having another same variable in there. So I'm going to call this f of t because letters don't matter. dt. So the letter inside the function does not matter. I can choose whatever letter I want. So that would be the area of the shaded region, which is all I'm asked to do here. I'm going to be connecting derivatives and integrals. Ooh, that sounds fun. All right, so let's evaluate these. So we've got 3t squared minus 6t plus 2. So that's going to be t cubed minus 3t squared plus 2t, evaluated at 3 and x. So that's going to be x cubed minus 3 times x squared plus 2x minus 27 minus 27 plus 6, so minus 6. Okay. Let's do this one. So that's the same function, right? So t cubed minus 3t squared plus 2t from 3 this time to x squared, okay? So x squared cubed is x to the 6th. 3x squared squared, which is x to the 4th, plus 2x squared, minus 6. And then same thing, so t cubed minus 3t squared plus 2t from 3x to x squared. So that's going to be x to the 6th minus 3x to the 4th plus 2x squared minus, I got to think now, so 3x cubed minus 3 times 3x squared minus, not plus, 2 times 3x, so 6x. All right, so I did those. Let's take derivatives of what we did. That's what I meant. Okay, so, boom, I recreated them all. And let's see. The derivative of this one is 3x squared minus 6x plus 2. Because the 6 goes away. The derivative of this next one is 6x to the 5th, 12x cubed, 4x. 6 goes away. And then the derivative of the bottom one is going to be 6x to the 5th, 12x to the 3rd, 4x minus 3x squared times 3 minus 3x to the 1st times 3 plus 6. And let's see if we can look for patterns. So if I take this one, what can I take out? I can take out a 2x. If I take that out, I'm going to have 3x to the 4th minus 6x squared plus 2. All right? And then if I do the same idea with the pieces down the bottom, again I'll have 3x to the 4th minus 6x squared plus 2 times 2x. And then, seeing I missed a parentheses here, I can take a 3 out from everyone, right? And I'll have 3 times 3x squared minus 3 times 3x plus 2. Ooh, that's interesting. So I started with, you should see some connections. I'm pausing to give you a moment to think. I started with 3t squared minus 6t plus 2. So I started with what we have up here, or here, or here. This right here looks a lot like 3t squared minus 6t plus 2, except t is 3x. Could I think of this piece as that. So could I think of 3x to the fourth as 3x something squared? So x squared minus 6x squared plus 2. Okay. So there's an x squared there. Is it fair to say it looks like the x squared is just plopping in there, the 3x is just plopping in there? Okay. Then, if I look at this again, and I look at the piece afterward, well, when I was plugging in 3x, I have a 3. When I was plugging in x squared, I guess I should have fixed the parentheses on that to make it more obvious. Boop, boop, squared. When I was plugging in x squared, I have a 2x. Aren't those the derivative? So I plug the pieces in, and then just put the derivative next to it. Alright, so that must bring us to this. FTC derivative. If f is continuous, we define f to be that integral that we talked about a little bit. Then big F is continuous and differentiable because we built it that way. F is an antiderivative, yep. Okay. Oh, okay. So if we take the derivative of this integral, we just get what we started with? Oh, that's not too shabby. So I like to make it wacky. Here's mine. If I integrate from g to h of f of t dt, let's write a step I don't need to actually write. So that's going to be f of t, big F of t, where f is the underderivative, from g to h. So that's going to be f of h of x minus f of g of x. But really I'm taking derivatives. So if I take what I just wrote, and I take the derivative, which is what I really want, I want the derivative of the integral f of t dt. That's going to be the derivative of this piece over here. So it's going to be f, big F prime, so I'm going to write it up top. So the derivative is going to be big F prime of h of x times h prime, because that's chain rule. Then same idea for g. But big F prime is little f. So little f of h of x times h prime minus big F of prime of g of x, so little f of g of x times g prime. So basically, I don't need to find the antiderivative. I can take the function, plug in the missing the pieces, and then multiply by the derivative of those pieces because of chain rule stuff. Let's see this in action. So f prime of x is going to be negative 2x squared plus 2, parenthesis error. There we go. Times 2x minus negative 2 times negative 1 plus 2 times the derivative of 1, which, oh, so that just goes away. So it's just this piece here. For the 2 on the bottom, I just ran out of room, so I'm just going to do the 2 on the bottom. That's t to the negative 3. So that's going to be x cubed to the negative 3 times 3x squared minus 2 to the negative 3 times the derivative of 2. That's 0. Okay, so that goes away. So I just have this piece. And then for 6, it's going to be negative 2x squared minus 2 times 2x minus negative 2x minus 2 times 1. Got it. All right. That's a crazy one. We're going to have to play with that. But I think I got some foundation pieces.